Now I'm too quiet. Hello everyone. We are live. Cool, everyone got a seat? Everybody got a drink? Everybody comfortable? All right, welcome to the 86th Melbourne AWS user group. We have a lot to get through tonight. Two fantastic presentations, so I'm going to spend as little as time possible on this stage for you. Hopefully we don't have too much feedback. Can you guys still hear me towards the end there? Everyone hear me okay? Cool. All right, so very briefly, tonight's introductions is me. We'll have a quick news segment with Chris and Ian, our other two organisers, and then we will drive straight into the presentations. First one is Jean-Manuel, who will be going through hacking private S3 buckets. We're actually going to split this up a little bit because it's quite a detailed presentation. So we're going to run through a demo of the problem. And then we will, I think you've got two demos, right? Yeah. It's going to be a very involved night. Two demos, then we'll have our quick pizza break as at our standard 7 o'clock time. And then we'll come back straight after the pizza break, finish off with Jean-Manuel, just going through the tips on how to protect against the hack. Yep. And then we'll have our second presentation with Iman. Iman, are you here somewhere? Haven't seen you? Oh, hi. Sorry, I didn't come and introduce myself before. So you'll be straight up after Jean-Manuel. And hopefully we still wrap up around the 10 past 8 kind of mark, at which point help yourself to whatever's left, back up and get out of here. Just a couple of quick housekeeping things. The toilets, if you're new here, are just down around to the left, around the back. Please try and keep the room tidy through the night if we can. If you see any empties on the floor, just throw them in the bin on your way out. So none of this is possible without the help of our sponsors. And our gold sponsor for this year has been Enabler. So a quick round for them. They pay for our gear, the pizza, the drinks, help out with the catering, so all that sort of stuff set up. We also have our silver sponsors for 2019, which is AC3, iCloud Guru, and Parallels. And our venue here we are tonight is YBF Ventures. They've hosted us all of this year and most of last year. And AWS themselves actually help pay for the cost of cleaning and running the venue as well while we're here. So big thanks to those guys. So who are we? We're your organisers for this year. My name's Rob, and we've got Chris and Ian down the back there. They'll come up here and do the news in a moment. So we run most of this meetup out of the Slack team that we have. It's a fairly active Slack team. There's about 500 or 600 registered members, of which 70 or 80 are active during the day at the moment. It's a great place to ask questions, to make connections, look for work, that sort of stuff. We also have an announcements and outages channel, so you can keep track of what's going on in AWS and discuss it. I thought I took the slide out. We have a website this year as well, which has actually been very helpful in communicating with you guys without having to go through meetup.com's crappy little box that we're allowed to use. Posted up there, we have our code of conduct. If you're new around here, I strongly recommend you have a quick read through that. It's fairly standard for meetups around this area, but we want to try and create as welcoming an environment as possible. So if there's any questions, or if anything's happened, please feel free to read through the code of conduct. It has ways you can get in touch with us so that anything can be handled very quickly. We also post our live stream, which is what's running on my tablet just there. And we post past videos when I get a chance to edit them. We do have last month's videos ready to go. I just got back from Singapore, so I haven't had a chance to post them up yet. That'll be in the next couple of days. So what else is going on in the AWS space? We only really have the one thing, which is our monthly reminder that reInvent's coming up and if you have a chance to get there, you really should. On their website, which is not on there, should put that on there, on their website they do have forms and letters and things that you can give to your boss to try and convince them to pay for you to go, if that's something you're into. Do strongly recommend you look into that if you can. It's a great week. You learn so much in a very short time. So that's it. I'll get out of the way. Chris and Megan.
This work? Yep, cool. Hi there. Just go through the news quite quickly. As said, Jean-Manuel has a long presentation. Like to start with what has finally come to Sydney, and that's basically nothing this month. A couple new ARM instances are probably the only interesting bit about that. So
let's get on to the good stuff.
Let's go on to the good stuff. But first,
serverless. Yep. Announced on the blog, Lambda is going to see some improved performance when you run it inside of VPC, rolling out over the next couple of months. So Lambda's a serverless compute offering that AWS offer. When you run that inside of VPC, there's currently a bit of a boot up time for that first invocation because of attaching elastic network interfaces. So the architecture for that's changed, and it's all described in a blog post. So do check that out. It's going to roll out over the next couple of months, and we're going to see dramatically different performance profiles for stuff running inside VPC. It's really exciting.
Yeah, unfortunately, it's not really here yet.
It'll be here soon. So just keep checking your console every day. The next one, step functions, dynamic parallelism. Again, step functions are great. They're a way that you can run. You can describe your application as kind of like a workflow, and now there's some additional options for dynamically parallelizing tasks. Given the time we've got tonight, we won't go through that, but definitely do check out the blog post on that. Same for the NoSQL workbench. Just give that a try if that's something you're interested in. One of the big pieces of news, though, is this Aurora Serverless data API. So rather than having to set up a JDBC connection to talk to your database and manage connection pools and that sort of thing, you can use a data API to communicate. Previously, that was available for Aurora Serverless MySQL, but it's now released for Postgres, which is fantastic.
Which is always good. More choice is better. So.
Here we go.
Last month we missed the containers part because some people decided, with me not being here, it could be skipped.
Jean-Manuel, that was his decision. He decided to skip the containers bit. That was not on me. Well, there was nothing interesting last month? Well.
I'm not going to spend a lot of time on this today. The big thing is basically that EKS now finally has support for assigning IAM roles to your services. This was already possible in ECS, but with EKS you had to use third-party tools, or you just assumed the role that was given to the instance, which is really not perfect in any way, shape, or form. So that's a big improvement. Definitely look into that. The other thing, Kubernetes 1.14, new version, always good, but be aware that AWS only supports the last 3 versions. So if you were running 1.11, that will automatically be upgraded to 1.12 next month, I think. Don't wait for that. That might have some unforeseen consequences. Then on the EC2 VPC side of things, session manager port forwarding, this may not seem like anything really interesting. Personally, I found it's great for connecting to Windows instances, as you don't need to open up an RDP port anymore. You can just use Session Manager to forward your port and connect locally. Made my life a lot easier, especially in an environment where I always had to switch VPN connections. And VPC flow logs metadata is probably more interesting.
Yeah, so I've got a background in operations, and so we'd typically get the flow logs in, and then we'd have to go and run some scripts to augment the flow logs with additional data, with additional metadata. So it meant having a whole bunch of automation behind the VPC flow logs to actually get the information we wanted. But now VPC flow logs, you can select which additional metadata you'd like, and they'll just automatically add it. And for the use cases, we were using it for troubleshooting and that sort of stuff. All the things that we used to do with scripts, we just burnt now. Because they're out of the box with VPC flow logs, and that seems to be a pattern with AWS. I'll build a bunch of stuff and automation, and then 6 months later it'll all just be useless because it's available as a tick box. But that's good, yeah. I think.
I feel like a lot of us have had that experience in the past. So moving on to the last part, some other cool stuff that has been released.
Yeah, best name of a service ever. Quantum Ledger Database.
Doesn't have anything to do with anything quantum, but you know, it's in the name.
It's now my preferred database of choice. For anything.
Yeah.
Is that why it's in the cool section?
Just because of the name. That's why it's in the cool section. Yeah.
It's basically an adding-only database. You can use it for auditing purposes. It's basically blockchain, but monolithic.
Somebody get this guy a drink. He said it. All right. Yeah. Next one is pretty cool.
The next one is quite cool. So about 4.5 years ago, AWS made it possible to automatically replicate your S3 bucket's contents to other regions. I don't know why it took them this long, but now finally you can do it within the same region. Especially for us here in Australia, where we probably deal a lot with data having to remain onshore. That means, again, we can get rid of a lot of scripts we wrote previously to do that for us. Now it's just a setting, the data shows up in your audit account or backup account or whatever, and you're good to go. The other thing worth pointing out is the auto-remediation features for config rules now. This was already sort of possible through AWS Labs, but it's now a native feature. Basically, if AWS config can check, are my services compliant with this thing or that thing? And now it's possible that if something is not compliant, you just tell it to fix it for you. So say you open up port 22 to the world, not a good idea generally. You can now have it automatically get closed. So, pretty good. And of course, everybody's been waiting for the ability to take the cloud practitioner exam at home.
All right, that was a speed run of the news this week.
Yep.
Thanks, Ian. Let's go.
All right, we'll just get set up quickly. There are heaps of chairs down the front if you guys want to sit down instead of standing at the back, but yeah. We'll be set up in a couple of moments. You can sit around the end there.
Well, I need to see the screen.
Oh, right.
Yeah.
Fair enough. All right.
And I'm going to use that as well, yeah. Cool. Extend desktop. Okay. Hi, I'm J.M. Becker. I'm very excited today to present the hacking of a private S3 bucket in under 2 minutes. It's a demonstration. There was an event in a fictitious company. I cannot talk about that company right now. That happened maybe a couple of months ago. And I'm going to show you how you can prevent it. I think it's changing a lot the way we're going to design application inside the AWS space because it's a very serious, as you're going to see, event. So a bit the agenda of today, what could have happened in that fictitious company, how the hack works, and how it kind of developed and over the time and over the cloud space. I'm going to do a live demo because I couldn't believe it myself that was even possible to do that. So I built a full demo, a full environment, and test it. And then I'm going to show you a demo of the fix. A lot of the blogs who are talking about that event or other events related to that type of hack has been very verbose about what not to do, but nobody I've seen so far tell you what to do to prevent it. So I designed 6 solutions, and this solution can work together or they can work independently, and they're all going to fix it. So I'll do a bit of recap of how that company, fictitious again, messed up, and then why they were hacked and so many people were impacted, and then a review of the complete solution, and we can have some questions. So we might, in between the demo of the fix and then the prevent it, we're going to have some pizza. I don't want them to turn cold. So what could have happened? And so first, a bit of a disclaimer. This is a work of fiction, right? Any similarity with actual person of companies is pure coincidence and unintentional. So there is a lot of legal implication in there. So it's all pure fiction. So what happened in that fictitious company a couple of months ago is 20 gig of data were exfiltrated from several hundred S3 buckets. These buckets were encrypted with server-side encryption, and that impacted 100 million customers. So if you want to know about it, just Google around, and then you will see what could have happened. So I did a lot of reading, like I said before. Very few are presenting some solutions. So these data were containing PRI information, bank, credit card number, addresses, date of birth, I mean the lot. That's something you want really to keep very private. The potential hacker used Tor exit node. Hopefully everybody knows what Tor is, the network for the dark web, and a lot of anonymous VPN. And it took more than 5 months to discover that hack, right? So someone goes in, gets your data out of the AWS space, store that into, I don't know, a USB or an hard drive, and then suddenly 5 months later, report it. And it's only when a security engineer from another company discovered that on GitHub that was reported back to the company. And they found out because they had some logging, but they didn't know for 5 months. So, and inside that published of GitHub, there is some likely other company because there was some name here of other company. Of course, they all denied what happened. They probably don't even know. So it hurts when you see this kind of stuff, right? Because I work in the cloud for the last 6-7 years, and when you see an S3 bucket getting hacked, you say, oh, okay, yeah, another guy who did a public S3 bucket. That really something not to do. But in that case, it's really different. All the buckets were private. So in recap of the environment and the different court cases were in place for this fictitious company, the attacker gained access to a set of AWS keys, right? Not the normal keys, AWS keys, accessing the EC2 metadata service. So it's not a guy who uploads this key on GitHub and then everything gets hacked from there. That's not the case. The hacker was able to get access to the EC2 metadata. We're going to review what it is. To a misconfigured WAF instance, so it was a public instances, open to the world. It was supposed to be a WAF to protect that company from services with SSRI vulnerability. So how it works. The hack has 3 components. Well, actually the first one, AWS metadata, is not a hack. It's just exists. It's what AWS provides you as a metadata. And then SSRF on mod security or Apache module mod proxy. So it's 2 open source products who propose WAF, who can run on the EC2 instance, and obviously they are cheaper because they're open source. And then there is an IAM role misconfiguration. That's a misconfigured component. So can anybody tell me what SSRF is? And I've got some swag, some t-shirt from my company. So I've got 10 t-shirts, I've got 10 questions. If people are interested, first person who answer, get the t-shirt. SSRF, anyone? Very good. You can get your t-shirt if you want. I've got different size. I guess you want to help, Chris? I've got large or I've got medium. So SSRF, server-side request forgery, and we're going to see in detail what's implied and how does that work. So let's recap first on metadata and what is the AWS metadata. I'm not sure if everybody knows about it, but it's a service from AWS. So it's a AWS Associate Certificate question. Can you tell me how to access the AWS metadata service from an EC2 instance? Anybody? Associate level. A t-shirt again. No? Yeah? Yep, that's enough for me. Perfect. There is probably a smaller size as well. I will check. You give one away, yeah? The first person. So that's correct. We have 168.254, 168.254, latest metadata. You can access all this information. So it's very useful when you are inside the EC2 space to be able to access that environment, to get information about IP, MAC address, all sorts of things that you might want to use inside the environment to configure your machine, for example, or to report to other things. So when I do that, inside my machine, I do a curl, HTTP 165.254.254, security credential, the IAM component of it, I get the role attached to that machine. So a role for a machine is a set of policies that are attached to that machine to allow that machine to access other AWS services, like S3, like DynamoDB. So This is a recommended feature from AWS. You don't want to have hard keys inside your EC2 instance hanging around. They recommend to use a role, and that the role has temporary information in it, and this will rotate the keys. But if I get the information next, I add that to my request, and suddenly I get this. That's a very long response. And what we see inside, we get access keys, secret key, and token. So for people who are familiar with the CLI, this is what we need to be able to set up our CLI inside our laptop to be able to access the AWS environment through the CLI component or PowerShell or other things. Here the difference is we have a token. That token has an expiration. You have that date when I capture that in my account. That date is in UTC time. Usually it's around 5 to 6 hours from the time you request that key. So that key has a time to leave as well. AWS doesn't rotate them all the time. When you see that key, the whole key changed, right? Not just the token. The token is a time token, but everything changed. The access key is a secret key. So that was the metadata. Any question? That? Everybody comfortable with metadata? Yeah. And all of that is you can access that inside the EC2 instance. You get this information. You don't need to authenticate. You don't need anything. The only thing AWS will check if it's coming from your machine where you ask the 168.254. It's not a network, so you can't work that through security group or through knuckles. It's talking directly to the hypervisor. We'll see in detail how it works. SSRF, so we saw server-side request forgery, probably on mod security or on Apache module. So what is in detail a server-side request forgery? It's a vulnerability which allows an attacker to make web requests from the context of the server host machine to arbitrary URL. So in short, is allowing an attacker to access internal resources who are not accessible from outside. So you ask a server which is inside to do a curl for you. So it's a curl into a curl. So we're going to see in detail. And obviously you can ask him to that particular IP because you will inject the web server, ask the 168.254, and it will reply back to you. So how does that work? We have here a simple environment. We have some internal web servers, a protocol, a different protocol, admin console, and then the HR application. That application is always obviously just private. They probably have just a 10 or 192 IP address, not even routable to the internet. So our hacker cannot access that application directly. However, he discovered through 1 million of bots they are running across the internet, some application could be vulnerable through SSRF. So what's it going to do? We're going to create and craft a URL will contain the valid URL to access that web server, and then a second URL to access that HR environment. That's the first step. So what's going to happen? You're going to send that request to the web server, and the web server going to decrypt that first URL, execute it, and say, oh, I've got something else to do. I need to go and curl another information. And going to hit that HR environment, which is absolutely private. That's the second step. So the first step for the internal HR application say, oh, I know you, you are from inside, so I'm going to reply to you. So, sorry, I'll reply back to my web server. They are in the same IP range, or they have open security group, or maybe just is on-prem. And then the web server going to get that response and then put them into an HTML page for the hacker, and then reply back to him. So the full information went from an injection to a reply back through the web server back to you. So that's a full SSRF environment. So it's not specific to cloud. It's been around since 2008. Some people have been writing about it. In 2015, there was an RSA conference about it. Who were mentioning SSRF and how they could access maybe cloud metadata information. In 2017, there was more article on the internet on how to exploit SSRF. There's a lot of stuff on GitHub. I've got all the reference at the back of that presentation, so you can see. And in 2018, I think, Netflix wrote a series of articles talking about metadata risk and then how to protect against SSRF. And they invented a couple of proxy, a couple of systems, but apparently they've been complaining to AWS for a while to try to fix that problem. Again, it's not a problem just for AWS. Every cloud has the same issue. Some it's a bit harder to access than others. But Google, Azure, OpenOcean, Oracle, if it is a cloud, all of them, sorry, all of them have the 169.254, 169.254 as a metadata with different type of URL. All okay with SSRF? Yeah? So some possible SSRF example that I've got, and you will see here how it works, that curl into a curl. So the first one is the web server, the webhook, and we have invite the normal URL. I just ask the server to redirect me to something else, but I ask him to redirect me to the 169.254, 169.254, so that server going to execute that command for me. Another example, it's a view image, and this one is a bit scary as well. That's probably the older SSRF style to access a password file on the local machine. So something is not possible usually to hack a machine. It's not even a shell command, it's just a HTTP command, but written a certain way, that URL can be hacked. In PHP, for people who use still PHP, there's a curl exec command who can retrieve images from other website, do webhook embedded, all sort of things, retrieve stuff from other website. Basically, 80% of the case, they will be vulnerable to SSRF. So it's not a small thing. This one, the proxy, people know DuckDuckGo. If they don't want to use Google, you use that. That's a real SSRF hacking who happened on HackerOne. If you know HackerOne, it's a website for white hackers. They discover flaws, write to the owner of that website and try to get some bounty out of it, some money. That has been acknowledged by DuckDuckGo, and they were able to get metadata out of that environment. But nothing bad, it's a white hacker, but obviously a normal hacker maybe would have done other things with that. So that's a real one. And then the proxy config, and that has been published by Nginx to never use, but it's the one I choose to use for our demo to make sure it works. So it's just a proxy server who's just going to pass on anything I ask him to pass on. So that's a config of Nginx. So when I talked to my colleague at work, and a friend of mine told me, like, there's no way a developer will do that, right? It's like silly. You wouldn't allow people to proxy anything. Well, so I did some research. He said it's exactly as well. It's like nobody in his right mind will code something like that, right? So I've got 3,570 CVE related to SSRF, right? It's not small. It's a lot of type of stuff, and that's the one who has been reported. We don't know the one who haven't been reported. And I've got in there SAP, PHPB, Apache Roller, Hethio, GitLab, Magento. It's a massive problem for Magento. And it's 2019, that CV, right? It's not something in the past. And then Kibana, that's for one. Then we had here the mod security. So I did some research specifically on mod security to try to understand if I could find the type of flaw the hacker exploited. So obviously I don't know if it is this one or not, but this one dates from 2013, and this mod security allows, as you see, HTTP requests to intranet servers, so the 169 is one of them, and to be able to access that information. And it's a complexity very low and a very high CV score, because you need very little knowledge to be able to execute it. So again, bots do that all the time on the internet to try to research that information. Another possibility for that hack would have been the mod proxy from 2011. In this one, it's a reverse proxy, was being converted to a proxy with the @ symbol, and forced the reverse proxy, in fact, to do proxying of data. So again, you know, people think that, oh, I've got a reverse proxy, I'm good. No, actually you don't. That can be hacked, and that's open source document. So when you look at it, say, oh yeah, 2011, 2013, that's pretty old, is it? Can you tell me if anybody ran 2003 server in production still? Like 10 years prior to that? Or Apache 2 on Red Hat 5? Nobody? A bit shy? I know it. A lot of customers of mine do that, and we try to convert them. So even this one have more recent, so not everybody patch everything, right? And this one is interesting as well. Again, on HackerOne, US Department of Defense running a Jira instance which is not patched and vulnerable to SSRF. And the guy again on HackerOne didn't hack anything. He just say, hey, I can access your machine, I can see your metadata, you better do something about it and give me some money. So critical, 9 and 10, disclose, limited, so you don't know how much the guy has been paid or what they fixed or anything. But they probably just had to patch that instance to stop the SSRF. So SSRF is really a big, big problem. And I think it took a really nice, big volume of interest on the hacker side, and being in the cloud, having that vulnerability with AWS metadata, that's a big problem. So the second problem, because the first one, metadata that exists, the first problem was SSRF injection, and the problem is the misconfiguration, obviously, of overly permissive instance profile. If that node or that instance had a profile too permissive, then suddenly the key are going to stall from going to allow me access to all the S3 bucket. And it's probably what happened. So we had probably a policy like this, which is pretty lazy as a developer, but I know a lot of people are doing just for port, just for testing. Even the SAM profile, the SAM framework, create by default S3 star, which is pretty bad. So have a look at it. Now, get, list, and resource star. So there's no way an instance need to access all the bucket inside your account, except if you are really doing a small environment, but please limit it to what needs to be accessed exactly and what type of environment. Talking about lazy, sorry AWS, but this one is bad. The AWS default SSM role, the old one, name EC2 role for SSM. At the end, you have exactly that, resource star for all your S3 buckets. So you want to use SSM, you want to use SSM manager, you don't want to do Bastion to protect you, and then boom, if that box has SSR vulnerability, people could access all your buckets. So at the top, AWS say explicitly, this policy has been deprecated, please use the other one. And the other one, of course, doesn't have any S3 at all. It's just about EC2 and SSM. So do not use, by default, roles. Even Elastic Beanstalk, even OpsWorks, all of them, they are a bit, yeah, some are good, some are bad. The worst part is the hacker know the role name. So it's really well known, and there is a hack in my reference where someone know the role, attack the machine, get the keys, go in the zip file, put a shell into the zip file, redeploy that to EB, and then suddenly it's got a shell inside your environment, inside your web page. So be careful with roles, least privilege always. So demo, I couldn't believe it myself, like I said before, so I had to build something. We're going to demonstrate to you how I can steal the keys, access an S3 bucket, download data, and 2 minutes, hopefully, if I don't have any technical issues, from our environment. So what my environment looked like, I built that. I was inspired with Rhino Security, which is a security firm in the US, and they build Cloud Goat, and they are specifically designed to be vulnerable, to do some testing and understanding how the hack works. So it's a simple environment. So I went further than the hack. I decided, let's see if I put that instance in a private zone with no internet access whatsoever, no NAT, no routing, nothing, just in private zone, and the application load balancer in the public zone. So it's the way we design VPCs in my firm. We have a public range, which is routed to the internet with internet gateways, a private range who has NAT or service endpoint, and then a database range if we need to put highly restricted data. And then we have different network access lists inside that environment. I've got, obviously, the S3 bucket I want to access to. They're all accessible through the service endpoint from that instance. Again, there is no routing to the internet, so all my S3 are private. Obviously, I've used Route 53 from a domain I've got. CloudTrail, as a good customer from AWS, everybody use CloudTrail. And System Manager, because I don't want any bastion to access that box if I need to. So I'm using the SSM Session Manager for that. VPC for log, obviously, to trace everything. And then my bucket I encrypted with KMS. Cool? Demo. So stay with me. Don't break things. I need my glasses, sorry, I'm old. What do I get here? Yes, cool. So if I still have internet, yes. That's my bucket. That's my bucket. That's my console of the hacker, is in red. And that's my environment. So my bucket is the one I'm going to try to hack. SSRF demo, everybody can see? Can I zoom a bit more? Yeah? I don't want to zoom too much. Bucket and object not public, right? That's clear. When I go to my bucket, I've got properties, I've got file in there, access login, default encryption, IES 256, object level logging to do some tracking, permission. My bucket says, I activated the new security from AWS. None of my bucket can be public, so it's on. Nobody can see anything. It's all locked in, right? Let's go back to that environment. That's probably a key I would like to access to, and obviously I cannot open it. It will give me that access denied, or it will download it because I'm logged in, but it wouldn't access if I access the URL. I've got access denied. My instance is just a simple EC2 instance running Nginx. So if you know the name, let's zoom that a bit. It's my C3 instance, right? The SSID finished by C3. What do I have in that instance?
Sorry, you might make that full screen. I can't see it.
Okay. So I'm losing, if I go full screen, that might create me a problem later, but that's okay, I'll try that. I've got a role here, SSRF demo, WAF role, attached to that instance, and that instance is private, there is no public address, there is a T2 micro, it's all working, all fine. And I've got here my load balancer, which is public, this one, and I've got a listener on port 80, 443 would have been the same. And my target group has targets, and that's my C3 instance here, which is healthy. Yeah, cool? This is what I was scared of. If I go full screen, I can't get back, can I? Yeah, I can do that probably. Yeah. So let's have a look at what I can do. That's my Mac. If I tap on command here, it's my back. If config. Yep, that's my local IP. I use my phone for that. So yeah, I'm not connected to AWS. I don't have a VPN. It's all there. So let's have a look. AWS S3 LS. I cannot access the environment, right? That machine doesn't have anything. Now, so I'm going to copy and paste the different commands. They're quite long. I'm going to try to keep it under 2 minutes, so we can, after review each command in the slides, and I can explain how they work. So I'll probably go to zoom in that as well. Well, under 2 minutes, Chris, you want to time it? So first thing, I do my SSRF, I get the role name. So I was able to access this environment automatically by asking my Nginx to talk to my hypervisor. Second step, if I get the math right, I get my keys. Third step, and that's a tricky one, but let's see if I can do that. Bring to the screen. I've got my credential file here ready to go. So I get my access key. Pretty tricky to do from here. That's okay. My secret key. And my token, and if you look at the token, is always starting with A and always finishing with equal. It's going to be hard to do that. I'll save this file. Let's go back to my screen here. File save. Now I'm back to my console. Clear the screen. AWS, sorry. AWS S3 LS. Maybe if I type the command right. Now I can list the bucket. Now what else I can do? S3.
Jan,
Yes?
just do a live demo.
Yeah, and I'm thinking,
And it just worked, right?
again, I just failed.
Everybody go mad, come on.
Can I keep going? Yes. I'm going to sync the data from that private encrypted bucket, get the data, and do I have something in there? I can still get the keys, of course. Let me get my command. I wanted to show you AWS STS caller ID. And who am I? I'm C3. So my laptop, stealing the keys, for STS I appear to be C3, my instance running inside the AWS space. And let's see if I can see this data. Hopefully that's going to work. I'm accessing the file. Yes. And that's my credit card data. So 2 minutes, maybe a bit more. Yeah, it's cool. So obviously I don't want any of the data on my laptop, so I'm going to get rid of that. It's all clear now. So what else I can do? Because that accessing S3, but hacker don't stop there, right? They get the data, they want maybe something else. Let's see if I can do this one. I'm going to get all the EC2 instances. I'll go to EC2 describe. That's interesting. I get the instance ID. Now what else I can do? I've got the instance ID. Let's ask for this. Can you tell me what it is? How I can read that? A t-shirt again for people who want. Give me some info on this one. Yeah. How can I read it? Yeah. So that's my user data inside the box. And my secret key is, obviously there's nothing in there, but that's the user data on the box. Just a bin badge, UM update, and whatever people want to put in there. So do not put keys in there as well. A lot of people are doing that just because they use Ansible or other thing to do the configuration with user data. Do not put keys because stuff can be stolen. Yes? Rob? Yep, okay. So I was able to demonstrate, let's go back to this. So I go back to my slide, if they are around. Maybe I need to click on this one. And what do I have next? We can do that after the pizza if you want. Rob, or you give me 5 minutes? 5 minutes? Okay. So how the hack works, we have a look at the SSRF, how it was working. This one is a tiny bit more complex, but same step. Same diagram I had before. My hacker here injected an SSRF information and talk to the application load balancer on HTTP AT. The load balancer just forward the traffic to my Nginx, who could have forwarded traffic to something else. But obviously, my first injection is this. That's my website, SSRF demo get serverless, getserverless.com.au. So serverless is better because you don't have this, but you could still hack Lambda with the same process. So two parts of the SSRF injection. Here is a proxy, so I'm asking that proxy to go to that yellow URL with a host specified on 169.254, 169.254. And the EC2 instance oblige, go to the hypervisor, get me the role. So that's my step 2. I reach the hypervisor now, get the role, and I do my second injection, and this time get the keys and the token. I get the keys now, step 3. So my hacker has the key now. Simple. Enter them into the AWS credential in the default, or you can have -- profile hacking or whatever. So the 3 level. By default, when you set up your CLI, AWS configure, I just ask you for the first 2. The third one is AWS session token. So I get the key now. I can talk to STS. STS thinks I am the C3 instances. I am just the instance. So you're going to reply, yeah, I know you. You are C3. You can get caller identity. You can do S3LS. And you can do sync data downloading. You can access my private encrypted S3 bucket, despite they are all secure, but they're still in a public zone because AWS uses public environment. So I will do a demo of fix after the pizza. And I will go through all the different solutions, show you how we can block each different steps, and then how to have the complete solution to be able to don't have your AWS metadata stolen, because that's the purpose of it. Thank you.
So before we break for pizza,
Lots of pizzas. So before we break for pizza, we normally do our quick marketplace segment. So just quick show of hands, is there anybody that's hiring? 1? Just 1? All right. Oh, you're hiring as well? Okay.
Hey everybody, my name is Chris Evan from Enabler, and we've got a couple of open roles at the moment. So we're looking for some very strong lead engineers who want to branch out and lead their own engagements. We're also looking for some very good senior engineers who've got some great DevOps experience, who want to develop on the job and grow into that lead role. So if that's the kind of job career that you're looking for, come over and say hello, and we'll tee something up for next week. Otherwise, also John has got a bunch of roles, very similar, and
So Chris was from Enabler, our gold sponsor, don't forget.
Howdy, so John from Latitude Financial. So we basically do credit cards, personal loans, and we're competing with Afterpay in a buy now, pay later product as well. So we're basically undergoing a pretty big digital transformation at the moment, so hiring across web, cloud, data, systems engineering, a bunch of other roles. So if you are interested in the cloud, not necessarily in the cloud team, but there's other teams using the cloud, keen to chat and point you the right way. In our team, we're doing a lot of cool stuff. When this fictional hack may have happened, we the next day basically had a PIR because we felt it was too valuable to just learn from a big example of a kind of institution that was experiencing something. We just felt it was really real and worth running through. I think the night before it had already bounced to executives and we were keen to get what a fictional hack could have an impact. That's pretty big. So yeah, if you're interested, come and chat. We do have senior and lead roles, so in the cloud space, keen to chat if you're really looking for a career step.
Was there anyone else? No? Cool. So if you are looking or interested in those roles, we'll have a 25-minute break. Go and have a chat to the guys. Otherwise, we'll be back in about 25 minutes or so. The pizzas are just downstairs. The vegetarian's on the inside wall. The rest is all mixed. Yeah, help yourselves.
Hi, how are you?
You have a minute for a question
Yes, sure.
regarding this?
Yep.
Access key and security key. Where are they coming from?
The metadata service.
Yeah, but that's my account. So
Yes. Yep. Yeah, and it's okay. Yeah.
what is that IP password? We have users, when you create a user, you can assign keys. So what is that?
For every role, when you do STS assume, when you assume a role, you end up with a secret key, access key, and a token, which is time to leave. So when you create a normal IAM user, you have 2 keys, right?
Yeah.
They never expire, and you rotate them yourself. For every role you assume, from Yeah, time to play?
All right, everyone, grab a seat. Grab a quick drink. You've got 60 seconds. And there are heaps of seats up the front. Heaps and heaps of seats.
Ready to go? I showed the hack. I couldn't believe it myself. It's working. I can impersonate the EC2 instance inside my laptop. I can get the keys, get access to the S3 bucket who are private and encrypted. So after successfully doing that, I had to see how I can fix that, how I can help my customers really not falling in the same problem that that company fell into. So I've developed a series of fixes, and we're going to go through each of them. First, I'm going to demo exactly how that fix works. And yeah, we're going to review them in detail with diagrams. So I go to my AWS console. I got my EC2 instance. I'm going to connect to it through, I can't see that, the SSM service. That's why I can show you when I do the fix, my instance is still working. Instance manager, manage instance. So that's my C3 instance I was talking about before, and I'm going to maybe a bit big, start a session. So that's, remind you, it's a private instance in a private subnet. Can I see that screen? Yes, I'm here. So here I can do S3LS. Maybe if I type properly. I got my bucket, I can access my bucket, that's just my normal instance. I can run obviously the metadata command. I've got somewhere here, someone. Yeah, I can run this. I got my role here to appear on the side. So that's similar to the other machine. So now let's go to IAM, because I think the biggest problem that company had is really IAM. And I'm going to look at the role, and some people during the break asked me what was the role, and yeah, it's a step I forgot to show you guys. That's a role attached to the instance. So at the moment, my role is simple. I've got EC2 read-only, S3 read-only, and SSM managed instance core to be able to access that box. So obviously the S3 read-only, that's the one I show you to don't use, is allow, get, and list for everything, all my buckets. So I'm going to add a role. Sorry. attach policy. That policy is a simple policy. There is not much in it. It's deny everything if my string is not equal to my VPC. So I'm going to ensure that that role is going to be used from that VPC only. So I take that policy, I attach that policy to my box. So now my role has the 3 policies, and let's go back to my instance. I get the screen. Let's see if I can do a describe. I got access denied. Cool. Can I do S3? It's hard to see. S3. Sync of my data. Maybe ls. Cool. I've got access denied as well. So my policy works. Let's go back to. Let's see if I can still get the keys. So I still can get the keys. So I can't use that role outside the VPC, but I still can get the keys. So anybody has an idea or how I can stop that? T-shirt again. No? Come on. It's a HTTP. We have an access layer 7. AWS WAF. No? Web application firewall. No T-shirt. Oh, sorry. So let's see. I can't use the role now, so I've got that first level of protection, right? My hacker would have been kicked out. His bot wouldn't have worked. He wouldn't have been interested in my company. He moved on. However, I can still get the keys and maybe do something else with it. Let's see if I go back to the screen. Go to, that's going to be hard, is it? If you can't use the screen, that's pretty bad, is it? Sorry. So let's see, services. I'm not sure why, but I can't see my screen properly, sorry. I might need to go back to, let's mirror the display, shall we? That might be easier. Okay. That's pretty bad zooming, is it? Okay. So, role. Let's go and see my SWAF. AWS WAF. WebACL. So I prepared one earlier, obviously, that I'm going to attach to my application load balancer. Yay. So a couple of roles. At the moment, I had just a count role. Now I go into a block role, right? So you can set up your WAF if you're afraid of breaking your app into a block mode or a count mode. So let's go back to my console. Now, can I get the WAF? Obviously, I've got forbidden for the WAF will block me to be able to access that key. So, second fix. If I go back to my WAF, I'm going to show you the role. I've got a couple of questions for you with a T-shirt as well. So I'm blocking here 169.254, right? In my query, in my URL, in my host header, in my query argument. You need to, hackers are very inventive, right? Can you tell me what the other number look like and what it is? Anybody? The 0xA9, 0xFE, no? Come on, I've got t-shirt to give away. No, I don't have any IPv6 here, but that's a good point. That's something to look at, but no IPv6. Yeah? Yeah, so we have different type of encoding for the same thing, right? So I'm going to show you in detail what they look like, but hackers are very inventive, and if you want to take some photos of that. We have hosted in XZ at the top. We have dworld, which is XZ without dot recompiled to decimal. We have XZ without dots. We have here octal with padding, so they add zeros. And then if you put that in your web browser, you will get 169, 169, 254, 254. So it's not specific, right? It's just some people are going to say, okay, I'm protected 169, 254, yeah, but no, hacker will create these inventive steps. And even that is not enough. I will show you a bit later. So what else we can have as other service that I've got inside that environment who could have helped me, again, a t-shirt to win, who could have detected kind of monitoring tools, help me detecting this type of hack. Yes, t-shirt for you. Guard duty. Let's have a look at guard duty, what it tells me. Cool. He found it. As you see, I've got a couple of testing, 42 counts, right? But the last time 34 minutes old when I was using it. So it's not instant, but you can see that that WAF role were used. And if I go in detail, it tells me, which is funny, right? Credential exclusively for EC2 instance has been used with that IP address, which is my phone. Don't hack my phone. And it tells me exactly the role, what key, what did I do with it, where I access S3 or not, what is going to tell me in this one. I assume the role, I did an API call, describe instance, that's the one I did before, and my location and everything. So you got everything. But AWS doesn't do anything about it. That's your problem. That's why you need to get notification. That's why you need guard duty to be able to do something to block that environment. Cool? So let's go back to the demo of the fix. Do I have my slide? Is that working? So now in recap, how to prevent it. I said 6 solutions. I just have 3 in there. That was part of the demo. And my other instance obviously can still do S3 and all of that, because I just block if that role is used outside the VPC, then I block it. So recap, that's how a hacker, the 5 steps he used: SSRF injection, talk to hypervisor, get the key, talk to STS, talk to S3. Simple. Well, simple. So how are we going to be able to fix it? First, fix the app. Obviously, I don't want to fix the app. That's my demo, but you need to fix the app. Patch your application and operating system. You saw that every app, Jira, is not vulnerable anymore, or for that particular hack, but maybe for others. So fix the app, patch the OS, be diligent. Don't use old operating system. Never trust a user input. If I trick the proxy to use 169.254, this is not a routable IP. Why? The proxy just executed. So use input validation checks in your code. And then blacklist AWS metadata information as well, and IPs or URL for any sensitive internal URL. So what it looks like from our proxy fix, and that's open on GitHub or on Nginx website, do input validation, and then refuse any forwarding of a proxy, which is external proxy, to internal IP address. And here we got the 169.254, but other IP as well. Again, this one is interesting. It's the local IP, so the 127.0.0.1, all of that, hackers are trying that all the time to try to access the admin panel, to try to do all sorts of things. So use input validation. So that's our first fix, fix the app. Well, if your app is not SSR vulnerable, even if your role is quite loose, then obviously the hacker won't be able to get the keys. But never trust an app fully, and then new vulnerability or 0-day get discovered all the time. So second, and for me that's the most important one, account isolation. Don't have like in this fictitious company, 700 buckets into one account. And they were Parquet files, so that tells me that was probably a data lake somehow with all the stuff in it. And they use star, it's crazy. So create different accounts to limit the blast radius. If one account get hacked, the key get leaked through that method, then they will be able to access only that particular account and your sensitive information will be outside of that. Never use star in IAM policies. That's really simple. That should be for everyone at every level, for role, for users, for instance profile, for all of them. Never use star. Don't be lazy. It's not hard. Just spend a bit more time to craft your policy and then never use star, except for deny, obviously, which is covering a large environment. But every allow or please do not use star. Use that profile and instance deny policy I created, inspired from different blogs I read and different Netflix blogs as well. And I crafted some that you can reuse and take photos after that. To stop impersonation of the EC2 instance. That's very important. I didn't know what's possible, well it is, and I demonstrated that. And then enforce this privilege as well in your CI/CD pipeline through the IAM profile. If you have CFN NAG or other product to be able to monitor your information and what you deploy into your account, then you will stop developer to deploy star into your account. So what it looks like, that's a policy I've added, I showed you before, with the VPC information. So anything I got in that role get executed outside the VPC will be denied, only that content of the VPC. In that particular case, I use VPC endpoint as well because I didn't have any NAT gateways or any routing to the internet. So I had the 5 endpoint. That's the 5 I need. But just for S3, it's a routable gateway type of endpoint. You could have just S3. I had to use SSM endpoint and EC2 endpoint to do my demo and take over the machine. So that's a role. And then the endpoint I had to have to be able to use that. The other one, the interface, are a DNS construct. So when you resolve the endpoint EC2 messages to you assist, it will resolve to your local ENR inside your VPC. I can talk about it later. So that's a policy I crafted for people who use NAT gateways because when the instance talk to the STS environment, you might use your NAT gateways or your VPC or your VPC endpoint, depending on where you talk to. So this one will cover all the 3 possibilities with NAT. So that's a 3 IP, elastic IP of your NAT for the 3 AZs. That's the source VPC here at the top, and then the source VPC endpoint for the S3. So that will cover all the possibility that instance can talk to different services of AWS. So you apply that deny policy on top of your role, you fix for SSRF, and you protect your AWS metadata. So, fix 2, we stop the STS. STS says, no, you're not following the condition, you're not coming from the VPC, I will deny you. AWS could do that for us, but yeah, we had to do it ourselves. Step 3, web application firewall. Use string matching filters, and I say in an attempt, because you're going to see why. There is a lot of combination we probably cannot cover. So it's an attempt, so it's another layer. Security is always about layers. And use IP reputation blacklisting as well. AWS provide a CloudFormation template with blacklisting. There is other vendors as well, like Imperva or Checkpoint who offer blacklisting of IP. Every Tor exit node, every VPN anonymous, all of that will be blocked. And so you can use your console to ensure that people not from other countries who are hostile could access your website. So that's the rough rules I mentioned before. But that's just part of it. That's the one I decided to use and to show as an example. But that's a detail. We have the dotless decimal, which is, like I say, is exe without dots, and then we convert it to decimal. And that, if you put that in your browser, that will work. Dotted hexadecimal, dotless hexadecimal, octal, padding, and IPv6. That was your point before. Sometime, you force the IPv6 running in IPv4. So they're all of them, 169.254, But people are smart, and they mix it, and that still works. You might have hexadecimal first, doctal, and then octal with padding, all mixed. So possibilities are really endless, and it's really hard for WAF to be able to cover all the possibilities. And even if you could, they can do that too. They set up a DNS, and in that DNS name, they resolve the 169.254. The website say, oh, I need to resolve that name, go to the internet, resolve that WAF53 IP or others, and then end up fetching the 169.254 for you. So again, WAF is just an attempt, it's not going to solve everything. Then other IP as well were important, the 127.0.0.1. During my research, I found that interesting as well. That's a type of IP. They can inject, and then you will have basically the host, local host accessed. So IP reputation, that's a link from AWS. You can deploy that template, and that does a lot of stuff for you just automatically. He has Athena to check your logs. He had Lambda function who's going to do rate limitation. He's got plenty of good stuff, and almost costs nothing to operate, like $40 a month. And that will cover a lot of things: whitelisting, blacklisting, SQL injection, all sorts. But it's not everything, right? Again, security is about layer. So we have a WAF now. We protect our application from SSRF, and our hacker can't get the keys. Cool. Then fourth, anybody has an idea what we could use? Again, T-shirt to be worn to block. Yes. Scott. Yes, that's one of them. You can have a T-shirt. But this one is not that yet. We're coming to that. No? Bucket policy. That fictitious company probably didn't have any bucket policy, because inside the bucket policy, you can enforce an S3 bucket to be accessed only from a certain VPC or from a certain account. So why I was able to do it just from my laptop, from a remote IP or from a Tor node, that's the question. So bucket policy. You just need to be very careful when you apply them, because if you make a mistake on the naming, then you need root account access to be able to remove them. Because you can't access the S3 console, you can't do anything, any change. You will need to do the change from the VPC, or from, if the VPC doesn't exist, then you block. You need to use the root account to remove that policy. So that's an example of a policy. You can take photos if you want. Again, I denied any S3 action. For my specific bucket, I don't have any stars in there. And then for all the data inside my bucket, and the condition, if I don't come from the VPC endpoint, then I will not accept any traffic. Yes, sir. Okay, speed up. Here is for the VPC, same role. So for solution, I will block my bucket, and then even if the guy get the key, get SSRF, get all the way to my account, he won't be able to read the data. 5, guard duty, we saw it. You can have alarm and notification. Please do notification. You can use CloudTrail as well, and that's the error code you will get when CloudTrail detects that you are outside the VPC. So you can set up a filter. So we found the guard duty finding. I'll show you that screen. So you need to, enable guard duty is not enough. You need to go inside your CloudWatch, set up a rules, and then link that to an SNS. Otherwise, you need to go and monitor guard duty, which is not fun. So that will send you an alarm topics. You can do filtering on severity. Yeah, a lot of configuration you can do at that level. So 5, you want guard duty added to the account with alarming, and then log filtered in CloudWatch as well. 6, Scott, you found it. Client-side encryption, obviously that's very important. If that data was encrypted before being put into the bucket on top of serial server-side encryption, then the hacker will have had garbage data to read, because it doesn't have the key, or the key is hosted in the cloud system or other places. It doesn't have access to the KMS the same way from outside, and obviously there is a KMS policy allowing only that machine to access it. So that will have protected the data. So it's a bit of a pain though. So for very sensitive data, use client-side encryption. But for example, if you have a data lake, Glue do not support client-side encryption yet. So that's a bit of a problem. However, EMR does and Redshift does. So you can find a way with Lambda function, with other things, to replace the Glue job into using client-side encryption and proper keys. So here again, S3 bucket, client-side encryption, even if all the different products were not there, it would have been protected. Full recap, that's a full design, all about layers, and that's all the 6 solutions here implemented into the account. So any single of them will have blocked that hacker. So how they mess up? Obviously, they have a very overly permissive IAM role. I'll show you, it's S3 star, right? If you can access 700 bucket, there is something wrong in your config. There was no bucket policy, the application was not patched, and they didn't have any monitoring, because if they had guard duty, they would have seen it. So complex solution, 1, fix your app, 2, account isolation and IAM, web application firewall to protect your metadata, restrictive bucket policy, guard duty, and client-side encryption. That's all my 6 solutions. There may be more, I haven't explored yet, but that's a final solution. That's all the resources. I will put the slides on the environment, but questions. So go and protect your data, and your AWS metadata is critical. Thank you.
Thank you, Jean-Manuel. I have a few of my accounts that I need to go and review. If you have any questions for JM, please see him after. Iman, if you're ready, we'll get started off with the next presentation.
Oh, yeah.
Just pop that in a pocket somewhere comfortable. Just touch that zipper maybe.
Here. Thanks. Okay. Good evening, everyone. My name is Iman Yusuf. I'm a lead site reliability engineer and a technical product manager at CultureAmp. Today, actually, I'm going to talk to you about one of the projects we have done late last year. But before actually I go into the details of the project, I want to share with you what we do at CultureAmp. So at CultureAmp, we actually have one mission. We want to make the world of work better. So for this, what we have done is we built an engagement and performance platform that would enable organizations to easily, collect, understand, and act on their employees' feedback. So there is this continuous feedback loop, which help organizations to continuously learn about, how their employees, what their employees' experience look like, and of course, eventually improve that. I think for us, the bottom line is we want to make culture a competitive advantage. We want to help organizations build a culture so that it allows them to attract as well as retain their top talent. So we have been actually working with a number of organizations, and some of them you can see on the slide. They are household names. You have Airbnb, and we have Atlassian, car sales, realestate.com.au. These are all companies that we know. We also have AFL. So is everyone excited for this weekend grand final? No? No one? Oh, come on, this is Victoria. Oh, okay. Who did this? Okay, right, now heading to Europe, right? So this data sovereignty project, at CultureAmp, we actually, until quite recently, all our data was stored in United States. Now, so we get these prospects. They love our product, they want to be our customers, but the minute they asked the question of the location of their data, as soon as they learn it's, let's say, outside of Europe or outside of the country they live in, it will say, okay, it's a deal breaker for us. So for that reason, we said, okay, it is about time. We are going to build a new data center, and we are heading to Europe. So for that, our specific location is we chose Ireland. Now, when you head to Europe, there are different pathways, there are different streams that need to to work together in order to make this happen. So we have the technology stream, where it's all about, the infrastructure need to be built, you have to put all your platforms should be there, so that's one stream. The second stream is the security side of things. So we said, when we actually build our infrastructure in Europe, it has to be as secure as the infrastructure in US. So this is non-negotiable, and it's important for us. And the third part is the legal side of things. When you think about the legal, it actually starts from updating the contract that we sign with our customers up to establishing an entity in Europe. So there is a lot of things would happen between these two works that need to be done. But today, I'll be focusing on the technology. The main reason being, I was the lead, I was the lead for the technology stream, and I know, the thing inside out, and I would think this would be more, interesting for this audience. However, if you have any questions about the legal or security aspect of the project, I'll try to answer them at the end of the presentation. Okay, so this is what we say. Like in October 2018, we said we want to onboard our first customer into the European infrastructure by first week of April. That's the date we want to work with. So we said, okay, if that's the end date, so let's work backwards, and what are the things that need to happen now? So we said, okay, so this is October 2018. What we want is by end of this year, by end of December, we actually want to build the entire infrastructure in Europe. Let's try to do this. And then, of course, there might be some things that need to be fixed, so we have 3 months buffer to make things right. So with that in mind, if you think about it, December is a holiday month, so so what you will get is, at best you'll get 6 weeks, in the worst case scenario, like, if you are lucky, at best we'll get 8 weeks, at the worst we'll get 6 weeks. Say, okay, let's try to do something. So actually so my team, the SRE team, was primarily responsible to get this done. So of course, in order to do this, first of all, we need to understand what are the things that actually make up the cultural stack. So there are 5 things, as you can see on this slide. So I'm going to go through, like in this presentation, and share with you what we have done to actually recreate these 5 components in Europe. Now, first thing first, it's all about the foundation. Right? We need to get the foundation right. So speaking of the foundation, Culture Amp has been operating on AWS since day one. Now, I must admit, we have actually used AWS as a kind of traditional data center. We have not leveraged, the benefit of cloud computing until 3 years ago. It's about 2016 we said, okay, there is something more to this thing than we see, so let's start, using that. So before actually I go into the details, I want to just share with you some, trivia information. Like I said, our first AWS account was created in June 2011. So our first account manager was Russell Hall. Actually, Russell Hall is the number 4 Amazon employee in Australia. So same year, in December, our account executive became Andrew Ziogas. Again, Andrew Ziogas, he was the number 6 Amazon employee for Australia. So here is the thing, right? So we actually, Andrew is still our account executive, and if you think about it, our relationship has actually lasted longer than most of the marriages nowadays, isn't that right? Yeah? Okay, so one thing that I want to pick is, so one important year I want to share with you is like 2013, about where we actually benefited from AWS startup program. I believe there is similar program still exists. It's called AWS Activate. Effectively, what happens is, if you are at the early stage of, forming your company, you'll get some credits to use AWS resources, you'll get business support, and you'll get, free training, and there are also other benefits. And, if you are actually at that stage when you are forming your company, every help actually matters, and Culture Amp is very grateful for this support. So around 2015, we started this deep technical engagement with Amazon, and around 2018, that's when we had actually our first dedicated solution architect, Julian Bright. So he was our solution architect until a few weeks ago, and now he's replaced by Chris, who's standing at the back. Yeah, yes. Now, let's go to the foundation. So when I say foundation, what am I talking about, right? I'm talking about the VPCs, the subnets, the CloudTrail, the IAMs, the MEIs, this kind of things. So I think, imagine, so we were in AWS since 2011. When you're standing in 2018, this actually infrastructure has grown organically. And until 2017, to be honest, almost everything was created manually. Like we go to the Amazon console, you click on it, create your VPC subnets. But however, something happened in 2017. There was actually a turning point for the infrastructure management at CultureAmp. We said, okay, from now on, no infrastructure can be created from the console. Every infrastructure we have, we must have a script for it. We must have a CloudFormation template for it. And actually, that decision actually really paid off in 2018 when we were time poor to recreate the entire foundation. Because of that decision, actually, for us, it was easy. You say, okay, we choose that this is our new AWS account. We're going to use Ireland as our region. Take the scripts, rerun them, have your foundation in a few days. That was fantastic, right? Now, foundation is in place. Next thing up is monolith. Everyone has monolith. I expect every company will have their monolith. And if you look at the same architecture, it is quite common. It's the same. I'm pretty sure you have seen it in the past. So effectively, if you see it, what you are looking at is you have a web server, which is connected to a database, in this case, a Mongo database. In front of the server is you have a classic load balancer, right? And one thing is, if you look at the web nodes in the middle, next there is a small box which represents a cron. It kind of says cron. So this is actually, it's a snowflake. You have a special name for it, and the name is the Days Star. So there is a story behind that. I probably will share that at some other time. It's a long story. So it's a, it's a snowflake. Effectively, we run our background jobs on this server. Now, and if you look at this, you can see the assets, which are on S3 bucket. They are served by CloudFront, and our DNS is managed by Route 53. Quite common, nothing special. And we actually, this infrastructure is created using it's manually, and plus the configuration is done using Ansible. Now, we said actually luck would have it. Around mid-2018, we were actually working on a project to uplift the monolith application. So we said, okay, we don't want to manage this manually anymore. What we want to make is like, how can we automate that? Is there any possibility for us to do it? So as part of that project, what we have done is, instead of running our monolith application directly on EC2 instance, we Dockerized it. And we started running that on EC2, on ECS cluster. So what this means, as part of that project, the entire infrastructure of the monolith application was CloudFormation. The configuration was, everything was scripted, so it was ready to go. Again, we were quite lucky when you work on the data sovereignty project. We said, okay, it's all good, it's fine, let's recreate it, and we have recreated that. There is a but coming, but of course, it actually required quite a lot of code change. So yes, it's deployed, it's there, but when you try to access it, it's not working as expected. Because there is the code, makes some assumptions about where it's running, how things should come to it, how it would process. There are different questions we were asking. We were asking, how do we onboard customers, right? How do we ensure that a customer that is supposed to go to the European infrastructure doesn't end up accessing the US? How can you solve this? So there are, some of the code changes we needed to make. Actually, they were quite risky. They had a potential to cause a complete south outage. So it's not really fun. Even if we were able to recreate the infrastructure quite quickly, the code actually required quite a lot of work. So I said, okay, foundation, we have monolith. The next up is let's bring the microservices. So a microservice, for us it is just an application, but with a limited scope. It is independently deployable, and it's easily replaceable. So there is a debate about that, right? So I think microservices in general, they have a lot of benefits. So for us, these are the top 3 are the main important things. So the first thing is we actually, as soon as we embraced the world of microservices, it opened up hiring for us. So Culture Amp used to flood the Ruby Australia conference because, of course, we want to hire the most experienced, the most senior engineers. Our monolith application was written in Ruby. But as soon as we started producing, building microservices, we started writing microservices in Elixir, in Python, in Go. And this actually opened up the talent pool, which is fantastic. So the second one is system-wide outage is near zero. Because if microservice is down, it's not ideal. But the worst thing that could happen is the feature that relies on that microservice will not be available, but the rest of the system will continue to function, which is a good thing. And the last one is isolate security-sensitive components. Like security specialists, you find them, they are very limited. It's not like the resource that you can find in abundance. So what we want is we want to make sure that actually we can actually allocate our resources wisely. Some microservices, they touch PII data, they touch sensitive data, so they require a lot of attention to make sure that how things are protected really well. We need to go above and beyond. But we have a majority of the microservices, they have nothing to do with PII data, so baseline security would be sufficient for them. So we don't have to spend a lot of time looking after, make sure that things are as expected. So with this in mind, when we actually fully embraced microservices around 2016, and in 2018, when we were ready to recreate our infrastructure in Europe, we had around 20 microservices up and running. So the good part is from day one, all the infrastructure around the microservices, they were cloud formationed, and every deployment is it's a continuous deployment. As soon as the code is merged into master branch, within few minutes, it's there in production. So these are all the good things that are going for us. But the challenge, one of the things we found is it actually required a lot of effort from other teams. You see, the way we have is at Culture Amp, you build them. If you have a microservice, you are responsible for building them, maintaining them, supporting them. And the operational side of things are also the responsibility of the teams. So it's outside of the SRE team. So we had to nudge other teams to make sure that those teams, their microservices are actually recreated, configured properly in Europe. So that's one of the things that we need to deal with. Now, we have the microservices. So the fourth up is, these are the shared services. So when I say shared services, what I'm talking about is these are not the system that we own, but we are responsible for hosting them and managing them. So we have Splunk for logging. We used Billkite for CI/CD tool. We have VPN to ensure that, to control access to our internal systems. And we also have, Active Directory to authorize SSH access into our systems. So actually, when we get into this stage, we had a discussion. So we said, can we use the existing systems as they are? Because these are common, these are shared. Why do we need to recreate them? So I think for us, one of the main reasons was we actually wanted a complete separation between US and Europe. Because if you want to use Splunk, for example, the one which is hosted in US, now, whenever we are logging, we have to think about, is it okay for me to send this data into US? Am I actually breaking a contract? Am I violating a contract by sending the name of the company whose data was supposed to be hosted in Europe by putting that data name in US, this kind of questions. So because we don't want to think about this on a daily basis, it was actually easier to completely have its own isolated system so we can actually move fast. So we don't have to worry about these things day in and day out. So this is what we have done, shared services. And the last part for us was the SaaS integrations. So these SaaS integrations, these are systems, but we don't manage them. We don't host them. They are hosted by third party. So one good example is like New Relic. We use New Relic for monitoring part of our infrastructure. We use Intercom to advertise whenever we have a new feature is up, we can actually do that advertising through our product. So this kind of things, we don't control them, but at the end of the day, we need to know where their data center is. If the data center is actually located in Europe, we don't have to do anything further. But most of the tools actually we use, unfortunately, their data center actually exists only in US. There is no option of hosting it in a different country. So one example is the email processing system. So one of this email processing system, it is actually the data center is in US. For us is it actually okay for us to send the email of our European customer to this company? Is it acceptable? And at that point, actually, we start talking about considering maybe we should stop using this provider at all, and maybe we should start using Amazon Pinpoint. So these are the kind of discussions we have. So, like going back to the mission, like to our objective, we said, okay, so we said we want to build our cultural stack within 8 weeks in Europe, and I think the question is, when we reached the last week of December, have we actually done it? So this is, just as a reminder, these are the 5 components that's made up of the cultural stack. And this is the 5 things this is actually the result. We were able to recreate the foundation within that time period. We were not able to actually create the monolith app. The main reason is, yes, the infrastructure is there, but if the code is not working as expected, what's the point? So the monolith was not functional by the end of the December mark. Microservices, they were all up and running happily with no problem. Shared services, again, we not only recreate them, one thing we have done is, the shared services in US, they were actually created manually. We have actually used this opportunity to uplift them. So we created CloudFormation template, we kind of rewrite the scripts. So next time, if we are actually recreating the cultural stack in a different region, maybe that time around will be easier as well. And the last one is the SaaS integrations. Actually, when we reached the December deadline, we were not sure whether we are successful or not. The reason we were not sure is, one, some of them, yes, they have a European data center. We can easily move to that. We haven't moved. But some of them, they are critical for our system. And it would have been actually difficult either to find a replacement, or it might require a lot of effort from us to re-implement the functionality they provide for us. So what we did is actually we took this to our legal system, to our legal team. So this is what the condition we are faced with, what can we do? So finally what we have decided is we're actually not going to make any changes to our SaaS integrations. But the thing that we will do is actually we will tell our prospects, look, all your data is, of course, will be stored in Europe. However, this section of your data, we need to send it to this company. This section of your data has to go to this company, and this is how we will use it. Just being transparent about that, and that seems to be a workable solution, and that's how we ended up passing that hurdle. So when we actually do this, when we actually going through this project, we actually got a lot of help from AWS. When we have a question, for our solution architect or for our account executive, it was very nice to be able to get a quick response as well. Getting that advice, that help, that was really fantastic. On some instances, we were actually able to talk to Amazon engineers as well as product managers. It was really good. So I want to actually revisit, before I finish this talk, I want to highlight some of the challenges that we have had along the way. So the first challenge is getting the teams to prioritize the data sovereignty task. Imagine this is Q4, this is the last quarter, pretty much every team had an ambitious goal. They wanted to achieve something. So we are now in the middle during their kind of Q4, we are saying, okay, we need you actually to reprioritize, and we need you to deliver this. So it's it's a sudden unwanted gift that we brought to them, and that was actually quite a challenge, and understandable, the reaction as well. But we are lucky, all of the teams, they were able to make up that time and create their microservices, make it available in Europe. So we were lucky in that way. The other one is figuring out undocumented processes. So like I said, it took quite some time for us to build our US infrastructure, and some of the processes, they are in people's head, and some of those actually are no longer, some of the ex-employee, culture and former employees, they took that process with them. So we needed to it's challenging how things are work, how were they created. It's quite an interesting investigative time. Something that's related to that is discovering unknown dependency. So you say, okay, I have a system here, I'll just build it. So when you build it, it doesn't work. And you look at the error messages, it's not that helpful. It doesn't tell you much to go with. And that's also one interesting aspect that as well. It's quite an interesting process. And the last challenge, which I really like, this is my favorite, was defining the scope of the project. So I can assure you this project, if you let it, it could go for more than a year. It's quite easily, it will go for more than a year with no exaggeration. So I think what was important is for us to say, for us it was really critical to be very disciplined and to say, not to be sucked into the temptation where we want to make everything excellent in the new environment. We needed to focus. What is the minimum thing we need to do to ensure that we actually can serve our customers from a European data center? So we need to be asking our question, is it really necessary? Is it the thing that we want to have? Or is it a nice to have thing? Or is it a necessity? So this kind of questions we needed to ask ourselves multiple times during that period. So I think for us, one thing we learned is, I don't know what the format should look like, but I think we need to have some cloud-friendly central registry of assets. Because we need to know, if you are recreating your entire stack in a different region, you need to know what are the things you are creating. What are the things which are essential? Because in our case, we had to talk to different people, right, to say, okay, is this important? Is this the kind of things that we need? Like for now, yes, we have, let's say, we are working on building that asset, but we still have, a challenge defining how can we maintain this? How can you remove items when we no longer need it? Who is responsible for doing that? So that's the kind of things we are working with. So the other one is, I would say, is CloudFormation has been our saving grace. It is the fact that we had many of the microservices being CloudFormation from day one, and also we went through all the effort of writing CloudFormation template for our, the foundation of the infrastructure. It actually made a huge difference for us. It's fantastic. But the issue was, we had hundreds of CloudFormation stacks running. It is now next time when you want to create, what you have to do is you have to go to in front of the console. It could be your like command line, authenticate, create the stack, do that process many times until you create the whole stack. So that's why it's not really perfect. It's not good enough. We want to do something else. We want it to do different. So actually what we want is, we want to be in a position to say, okay, I have my foundation. I want this, the foundation is deployed and rolled out in US. What I want is now, I want this to happen in this account, in this region. That's it. That's all information we want to give, and we want that to happen. So actually, immediately after this project, what we have started is actually we have started working on that project. So we are using now AWS Cloud Development Kit, CDK, if you have heard of this, and also BuildKite together to be in that position. For now, at least, what we have done is we built the capability to actually, whenever a new microservices are created, they are configured in such a way that next time, if you actually want to redeploy that service in a different region or in a different account, all you have to say is, this is the region, this is the account, and it will happen. But what we want to do is that we want to retrofit that kind of capability to our existing, microservices, as well as all the foundation infrastructure that we have. And this is all that I have for today. I try to finish as quickly as I can. Okay, thank you. Yes?
Hang on a second.
How do you define the foundation, your foundation? Do you have a scopes?
Yes, I think like for the foundation, we'll say, we have VPCs, for example. Our VPC, we have our own, it has our own architecture. So we have a CloudFormation template which captures that. So the first thing we'll do as a foundation, like when we have a new account, we'll say, create this VPC. So that VPC is the virtual private cloud. It's the first VPC, it will contain the subnets. So we have actually a public subnet, a middleware, services subnet, like that. So we have different type of subnets. They are already captured in a CloudFormation template. So the other one, we have the foundation is, when you say foundation, we'll say our AMIs, Amazon Machine Images. So they are a foundation for us because we have, first of all our EC2 instances as well as ECS clusters, they must use a specific type of images. So that image is actually cultural branded images. So we have, look, there is a plain Amazon Linux, a plain Ubuntu. On top of that, we add some security controls to ensure that actually they satisfy with our requirements. So when we say foundation, this kind of things that will be used, that are needed to actually run our platform. These are the minimum things that has to be in place. Did I answer your question, or?
Yeah, I mean, foundation could be different. For my company, my foundation will be made different from yours. Or
Yeah.
How do you scope your foundation as well?
So I think the scope is, what is the infrastructure that is needed by all our services? Like at least by most of our microservices, by monolith application, what is the thing that it needs? Let's say on Amazon, right? Like you need to have a VPC to launch your systems into it. So without a VPC, there might be some exceptions, but most of the services cannot be created. So that's a foundation for us. I mean, the second foundation is like the IAM, for example, right? So IAM is central for everything. That's how you actually grant access, how you deny access. Again, that's a foundation for us. So did I answer the question? Okay.
Hi, thank you for the talk, very interesting. I have a question on some of the SaaSes.
Yes.
So, did you consider that some of the SaaSes could very well be replaced by services that are available in AWS? Like one example that came to my mind was the Splunk could not have been replaced by CloudTrail, CloudWatch combination type of thing.
That's a good question. We actually definitely considered that. So one of the things in my example, what I've shown is like the email processing system, that could have been replaced by Amazon Pinpoint, because Amazon Pinpoint exactly does even more. And in terms of Splunk, the issue for us is like in Splunk, we have a lot of configuration in it that will actually security alerting based on some kind of pattern matching. Let's say, okay, what are the things that are being logged? Based on that, it will automatically alert our security team. So yes, technically we can put different AWS services together to get it done. The issue is, like you see, the question is how long does it take? So we have rebuild Splunk with all the configurations that we know everything is set up, or figure out how we can recreate this using
Cool, thank you, Iman. That was very informative. Particularly, I hadn't considered the integration partners and stuff like that.